We've seen how alkanes, ANEs, are all single bonds. We've seen how alkynes, YNE, are triple bonds. Well, you guessed it, there's also a double bond between two carbon option, and that creates what's called an alkene. So an alkene is just an organic chemistry compound that has a double bond between two of the carbons. So you can see the generic representation of the alkene. Alkenes have 2 less hydrogens than alkanes, but 2 more hydrogens than alkynes, so they're CnH2n. And how you name these is you just, instead of name it as if it was an alkane, but then you take the ANE off and you put an ENE in. Now there's some interesting things about alkenes we're going to talk about. One of the things is cis and trans, and we'll talk about that in a little bit. However, numbering becomes really important. So for example, in the upper right-hand corner, that's but1-ene or butene, 1-butene. Either way is fine. That's 4 carbons, and the double bond is between the first and the second. That's why it's but1-ene or 1-butene. Either way is fine. A lot of times they put the numbers right before the double bond, the ENE part. So that's why it's, for example, in the lower left, it's pent2-ene. The double bond starts at the second carbon. That's why it's pent2-ene. Methylpropene there, 2-methylpropene, and ethylene or ethylene is its common name. They don't really need it. They're too small. Cis and trans we'll talk about here in a little bit, and they're really important. Cis and trans are only applicable towards alkenes, and we'll talk about why that is in just a second as well. But before we do that, which of the following could be an alkene? And again, for an alkene, if you look at that generic alkene formula, CnH2n, you need twice as much hydrogen as you need carbons. Well, sure enough, both number 1 and number 2 have a 2-to-1 ratio of hydrogen to carbon. And both of those, in theory, could be alkenes. Now, earlier, we talked about how number 2 could be a cycloalkane, because cycloalkanes also have CnH2n, and you couldn't have C2H4 be a cycloalkane because there wasn't enough carbons, stuff like that. Just realize that some of these will have the same structure. This is the joy of isomers, and we're going to see that a lot in organic chemistry. But anyway, both number 1 and number 2 could be an alkene. I would think that number 1 is probably going to be an alkene. I don't know of anything else off the top of my head that has that same formula. But number 2, like we said, that could be an alkenes, could be some kind of pentene, but it could also be a cyclopentane compound. So this is why you have to be careful when it comes to organic chemistry. Cis and trans is incredibly important. Cis and trans is when you have different orientations of atoms around the double bond. And we saw a little bit of this in chapter 19 with inorganic compounds. This is the organic chemistry version of cis and trans. And it's always around a double bond. So if you look at the left-hand side, the cis-but-2-ene and trans-but-2-ene, focus on the hydrogens. So the top one has hydrogens on opposite carbons, but they're both the same side. Like right now, they're both down, if you will, and you could flip it, make them both up, but they're always going to be the same side. The trans version below has hydrogens on opposite carbons, but opposite sides. So like the one is down and to the left, and the other one is up and to the right. And if you flipped it, you'd have one down and to the right and one up and to the left, but they're opposite sides and opposite carbons. So trans is quite different than cis. Trans will usually be less polar, just like we talked about with the inorganic compounds, while cis will be more polar. And it's very difficult energetically to turn a cis double bond into a trans double bond, so they generally stay there until they react, but they are very important. So cis and trans is important. That's why you see the names. Now, earlier in my career, if you will, we used to call it cis-2-butene and trans-2-butene. However, the shift is now definitely to call them more like this version, cis-but-2-ene, where the 2 is next to the double bond, and also then trans-but-2-ene. Honestly, for me, you can call them either one, and I'm totally happy. And you will see both of them in the wild, if you will, but probably the but-2-ene is preferred now to 2-butene. I'm just trying to give you all the hints and stuff so that you'll do okay in organic chemistry. This just shows how going from cis to trans, it takes a lot of energy. It's like in this example, it's about 240 kilojoules per mole, and that's a lot of energy. Now in these representation, pi bonds are basically going left and right on both the top and the bottom. So my two arrows there represent one pi bond. And to break that pi bond takes a lot of energy, 240 kilojoules. Now the sigma is between the carbons, and that's intact on both of them. But if you can apply the 240 kilojoules, you bet you can break it. You can turn cis into trans. But that's not an amount of energy that's normally available at room temperature. So usually cis is stable and trans is stable, and it's difficult to go cis to trans unless you know some kind of reaction way to make that happen. Cis and trans fats are super important for society, and trans fats are generally not good for humans, while cis bonds are usually better for humans. And I wanted to show you just an example of how this works out. These are two acids, and these are big biochemical molecules, and don't ask me too much about them because they kind of freak me out. There's so many carbons, but anyway, what I want you to focus on here is the double bond, all right? Now, both of these structures have the same formula, 18 carbons, 34 hydrogens, and 2 oxygens. But what's different is the double bond. So you can see in the lower part right there, you have like a up, down, up, down, up, down kind of structure. And the hydrogens would be opposite carbons, opposite sides. So that's a trans form of this crazy thing. Now on the upper side, the hydrogens opposite carbons, but they're both the same side, like they're both up right now, and if you rotated the molecule, they'd be both down. Well, anyway, oleic acid is a cis bond, a cis monosaturated fat, and it's found in olive oil and avocados. It's supposedly a healthier fat to have. On the other hand, that acid down below, I think it's pronounced ellatic acid, that's a trans fat. And trans fats are much more difficult to digest. They cause all kinds of health issues. Trans fats have more or less been banned in foods because they're so unhealthy. So just realize same structure, but just one different kind of cis versus trans bond will make the reactivity quite different and the effects on human beings quite drastic as well.